Okay, so we kind of saw the need for a more efficient approach to solve this problem of naive matrices, of monotone matrices, because our naive approach just took way too long to run, right? And we did not have that sort of time on our hands. So, and this was kind of a giveaway early on. We're going to do that by coming up with a divide and conquer approach to solve this problem of monotone matrices. And we're going to use the special properties of monotone matrices to achieve that, right? Okay, so let's get right to it. What I've done over here is I've sort of drawn out a m by n monotone matrix, and I've labeled the rows 0, 1 all up until m minus 1, and labeled the columns 0, 1 all the way up until n minus 1. And now let us think about how we can use a divide and conquer approach to simplify our problem, and really, like, instead of running our algorithm on the whole large matrix again and again, how do we run it on smaller and smaller chunks of our matrices, right? Okay, so let's get right to it. So we're given the information. Let's say that we're given the information that the minimum for row I occurs at index j, or at column j, right? So that makes things a little interesting for us, right? Because now this kind of partitions our matrix into 4 sections, right? These 2 sections that I've highlighted in yellow, and these other 2 sections that I'm now going to highlight with gray, right? So what does this tell us? Now, we know that by the properties of monotone matrices, if the minimum value for row I occurs at index j, the minimum value for all rows above I have to occur at indices less than j, right? And similarly, for all rows below I, the indices for the minimum values have to occur at columns that are greater than j, right? So that means now we kind of simplify our problem to these 2 smaller matrices, right? The one that is highlighted in yellow, and the one that is highlighted in yellow here. And kind of the gray shaded areas, those don't matter to us anymore, right? Because we know for a fact by the property of monotone matrices that our minimum values cannot lie over there, right? So similarly, let us say once again we take the matrix that's on top, and we find out that the minimum value for another row, I'm just gonna label it something like row A. Oh, actually, it's a bad name. For row B occurs at column C, right? What that does again is it will further divide that smaller matrix into 4 smaller parts, right? It'll divide it into the 2 yellow parts that will remain of interest to us, this one and this one. And it'll kind of tell us that, yeah, we no longer need to consider this area and this area, right? So as you see, for each smaller submatrix, we kind of just go on finding the index or the minimum value of a row, and then we sort of eliminate half of the matrix from consideration, right? The top right half and the bottom left half. And we can do this recursively and again, like we can constantly like divide up our matrices and sort of bring in, just get our minimum values of interest and then sort of put them all together at the end, right? So that's exactly what we're going to do. Before we go on to the next section of this video where we'll actually code up the solution, now that I've told you the main idea and we've talked about the main idea, I'd strongly encourage you, before you move on to the next video, to play with this yourself. Try to see if you can come up with Python code to solve this problem of monotone matrices. I've given kind of a giveaway over here. I'll discuss more about this in the next video, but yeah, try to figure it out yourself. And I think that'll be a really fun challenge to try.